first So let's first talk about the variable. So what do you guys understand so far? Anyone raise your hand? There are no wrong answers. What is meant by a variable? Anyone? You can be totally wrong, by the way. Anyone?
A variable is a value that can change over time.
Yeah, that's possible. Okay, what else? Okay, so variable is a characteristics that, a character or a value that is used in a study. So let's say I want to do a study where I want to see that people who have longer heights or who are taller, they have more IQ, right? So in this study, I would need to check. So let's say we have 39 people here, right? So my hypothesis is, which is just, for the assumption, my hypothesis is that people who are, taller among these 40 people. So can you guys mute yourself? So people who are taller among these 41 people who are in this Zoom room, who are taller, they have higher IQ, right? So what I need to do is, I will collect all of you, I will get your heights, and I will get your IQ, right? This is just an assumption. So in this, height and IQ becomes a variable. It's a characteristics. It's a quality that is attached. And because SPSS, for us to give instructions to SPSS, it needs to understand that, right? And we need to give those instructions in a way where it makes sense. So that's how we change it to the variables. That's the concept. So let me share my screen and go over the definition of variables. And please stop me at any time. So, variable is a characteristic. So like we talked about age, there are two broader types of variables. One is numerical, another is categories. That is based on categories. Just remember that this is just to make your job easier. Don't worry about the taxonomy that is used. Anything that is numerical, anything that is in numbers, that is called a continuous variable, right? So for example, here we have mentioned age in numbers, like 5, 5.5, 10, 15.4, 20, 20, 20. All of these are, because they are numerical values, they are numbers, we call them continuous variables. Does that make sense so far? Any questions? You can just say in the chat if you don't have any questions, so I get an idea. Okay, so let's go back to, so this is your, so I think I was trying to read up on Misbah on the discrete numbers. I think when you add, I agree with you on that. So let's see if it is, let me just make it easier for you. So 5, let me take out all the values. So this is a numerical value. When you add like 5.5 and 6.4, that's becomes more like a discrete variable. So when you have like a whole number, that is your continuous variable. When you have like in decimal points, that's, so Junaid, is it other way? Okay, let me Google this. So, and sorry, I'm not a statistician, so, and discrete variable. So let's look at it together. A discrete variable is a variable that takes on distinct continuous variable is a variable that takes on any values within a range. Yeah, so I agree with you. So you are correct. So a continuous variable would have decimal points like this one. So 5.4, so 5.5, 15.5. So that is your continuous variable. But if it is mentioned in a whole number, that will become your continuous variable. And these are, okay, thank you. So these are your numerical variables. The other kind of variable is, okay, other kind of variables are the one that are mentioned in categories, right? So when there is an order attached to these categories, they are called ordinal variables, okay? When there are no categories attached to them, then they become nominal variables, okay? So for example, if you want to look at the provinces in Pakistan, like Punjab, Sindh, KPK, Balochistan, you can mention in any order, right? It does not need to be in certain order. So that's when it is called the nominal variable. The ordinal variable is when it is given in categories, like ordinal variable is when it is given in order. Let's say if you're doing a satisfaction survey and there is, when it says like, are you satisfied with the services, right? Arranged like south to east. Yeah, I mean, Salman, you can say that, if we want to look at this way, whenever there is an order attached to, a categorical variable, that is called ordinal variable. So for example, I want to say whether, you are satisfied with the services that are provided at certain customer services. You can say strongly agreed. Answer would be strongly agreed. Agreed. Neutral. Okay. Disagreed. And strongly disagreed. Yes. Yeah, Junaid. So when there is an ascending or descending, sequence, that's when it becomes an ordinal variable. And when it is not, like I think Kader mentioned, like colors of car in a race, that becomes the nominal variable. Dichotomous is a variable that only has, no, it is not necessary for them to be in a certain ascending or descending order. I can say strongly disagreed at the top, disagreed on second, neutral third, agreed fourth, and strongly disagreed at number 5. So it should be in a sequence, but it doesn't have to be ascending and descending. Okay, does that make sense so far? So dichotomous, the word by itself says that it is dichotomous. So there are only 2 answers. So I can come up with, so in that case, Ahmed, that would be an ordinal. And I agree, like pain, mild, moderate, severe, if it is mentioned in an order, that will become an ordinal variable. For age, like, I think I mentioned it, like very young, old, or very old. So this becomes an ordinal variable. Or yes or no, there are only 2 answers, that becomes a dichotomous variable. Like gender, male or female, if we take gender as a binary function, right? That becomes dichotomous variable. Yes, you're absolutely correct. So remember, there are 2 types of variable. One is numerical, and one it is categorical. In numericals, there are numbers. In categoricals, there are categories. Now, they're divided further depending on how you arrange them. If categories have no order, that's an ordinal variable. That's a nominal variable. If categories has an order, that's ordinal variable. If there are just two answers to a question like yes or no, that is a dichotomous variable, correct? So Samra, let me give you an example, and then you can tell me, whether it's a dichotomous variable in a marital status. So marital status can be single, it can be married, it can be divorced, it can be widowed, right? So that would become, that does not stay dichotomous anywhere. So let me give you an example. Arfin, I will come to your question and see what you're asking. So let's see, we have weight. Let me share my screen and you guys are going to tell me what kind of variable that is, okay? I have a weight of the patient. So one patient is 150 pounds, other is 160, 170, 180, 185. What kind of variable that would be? How are we describing that? So that's continuous variable, right? Sorry, let me go back. This thing is still confusing me. So when it takes a distinct number, that's a discrete variable, but we can say it's a numerical variable because that's how we're going to put it into the SPSS. For weight, now let's go to the next thing. Thin. So low weight, normal weight, higher weight. What kind of variable that would be? Correct. Now, I want to say that now I don't want to do it in an order. I just want to ask someone, are your patients obese? Yes or no? So that's dichotomous. Okay, so remember, when they are in an order, that's ordinal variable. When these categories, they are not in an order, that can be either your categorical variable or your dichotomous variable. In dichotomous variable, there are only two options. Okay, does that make sense now so far? I will clarify on continuous and discrete variable. I can share in the group too. So it makes sense so far, right? So let's go to second concept now, which confused many of you. So let's see. I want to say that I want to check the mean weight for 100 people. Or I want to check the weight for 100 people, right? Are all of them, those 100 people, they're going to have same weight? That's possible. More likely it's not going to be possible because weight can vary. So I just want to get the average value, right? What's the average weight for that group? So what I would do in that case is, and remember, weight is, if it is given like 150 pounds, 60 pounds, 170 pounds, 180 pounds, that's when I will check for the mean, median, and mode, right? So for example, going back to our previous example, let's say these are 100 people and I want to check their ages, okay? Not all of them gonna have same age. So I want to come up with what's the average weight in the group, right? So what do? You calculate the weight of all people. So let's say there are 13 people here. You calculate their weight. You divide them by the total number of people, right? So here I will sum up all these weights I will divide by them by number of people. That would be your mean, okay? Mode is a recurrent occurring value. So what's the mode here in this? Anyone? You can be wrong, that's okay. So yes, 20 is the median. Let me make it simple for next one. Okay, now I want to calculate the median. Median is something that cuts across the values. So what's the median here? Okay. So far we read about, what's the mean, median, and mode. And I will show you how to calculate those numbers in SPSS. Before we go there, I also want to talk about one thing that, was quite confusing for some people. Let me see. I think I took the let me see. I think one thing that most people did not understand was that the normal distribution, right? So let me get a graph for you. So taking same example of the weight. Let me share my screen. So let's see, I want to calculate weight for 100 for people in Lahore. Okay. So will I be able to calculate the weight of all people in Lahore? Is that something that makes sense and good thing to do? No, because it's not possible, right? Because you cannot calculate weight for 15 lakh people or however is the population of Lahore at this time, right? Or New York, so to speak. So you need to see where it would make sense, how much people you need to. So there is a whole population, and then sample is a subset of population that will give you almost the results that you can generalize to the population. So that's what a sample is, right? Population is the whole population. So I'm sort of getting lost too. Let me see. Let me go back. So now when let's say, look at the weight of, let's say, I feel like 150 is a good number. And there are some sample size formulas that you can estimate based on. I don't know it yet, but I will ask some of the next speakers to, include that. So let's see in my sample, if it is a good sample, if it is a representative of population of Lahore or New York, and we are trying to calculate their weight, it should be normally distributed, because that's how you want to look at that. Normal distribution means that how data present. So normally data has an average value, and there are some variations from that, right? Those variations are called standard deviations. Okay, there is a standard value, and when your numbers deviate from that standard value, that's called standard deviation. Does that make sense? Okay, I just say yes. I just need to know that you guys are engaged. Okay.
Yes, sir.
Okay, so let's say, you picked 300 people, and out of those 300 people, if it is normally distributed, your mean, median, and mode, measures of central tendency, should be here at the center. Okay. And there are, if data, so let's say you were, a mean weight is 150 pounds, right? Your first standard deviation is at, and how to count for that standard deviation, I will show it to you. So for your standard deviation, when you say one standard deviation, that means, if one standard deviation is, let's say 30 pounds. So 150 is your central number. 185 to 100, I don't know what I'm calculating, 150. So let's make it, total number. 30 is your standard deviation. So 180 to 120, that's people who are you in your first standard deviation. People who are deviating, 60%, 8% of people deviate from the central value or standard value. So that's one standard deviation. And I will show it to you. For it, let's say for your second standard deviation, for the same number, 150 is your standard. First deviation is 180. Second standard deviation would be at 210. And on the lower side would be 90. So between 90 and 210, there are about 95% of people who are in that, should ideally be in that. Now, what happens? So let's say, going back to our same example, in this, we are calculating weight. 120, 125, 130, 140, and you are calculating the weight mean for that, right? Mean weight for that. Yes, Harfin. Yeah, so that's a good data, actually. And why it is important, I will show that to you. So for this, do you guys feel like, if we add this person, would that affect our data? Right? One at 180, would that affect our data for if we are calculating mean? Yes or no? Because that is an outlier. So your mean will appear on the higher side than it should be if your data is normally distributed. So that's called positively skewed. Now let's take out this value and we add 10 here. Now, this is going to pull your mean down, right? So your data is negatively skewed. Okay. Does that make sense now for everyone? What is meant by mean, median, mode? What is meant by positively skewed, negatively skewed standard deviations, right? Okay, good. If anyone is confused, I can explain this again. Please say so. Okay, so no one is confused, I assume. So let me go to SPSS now. So why it is important to show, sorry, Sarish, can you open your mic and ask?
Sir, I'm a bit confused about standard deviation. I got the concept of positively skewed, negatively skewed, but I'm a bit confused about standard deviation.
So standard deviation, let's say, if you have, 10 people and you're calculating their weight for the weight for those 10 people, do you think all of them going to have same weight or different weight? Can you
answer?
They're
going to have different weights.
Different weights, okay. So let's see, your assumption is that their weight is 150. And ideally how data should be presenting is that out of those 68%, out of the total 10%, 68%, which is roughly about, 6 or 7 people, however you want to do that. So 7 people should have variation within that, so one standard deviation. So let me go to, SPSS. I think it will make more sense there than, me talking in the air. Let me just go there if that is okay. Okay. So let's open SPSS. Now we talked about, and I just want to start it from the beginning. So, you guys know how does this open up the whole thing. So that now, because that's why it is important to know about variables, because all of these concepts going to help you run SPSS. And this is why I think we're trying a little bit more to know about the theory. So this is your SPSS. So here it is opening up on Mac for me. Okay. Okay, let me see. Open. Good. Do you guys see my screen? Say yes.
Yes.
Okay.
Yes, sir.
So here we have, about 12. This is, you see at the bottom, it says variable view, where it is whitened now, right? So there are two windows, data view, where there's individual data for all the patients. So yeah. And then there is a variable view where there are variables. So variables are our characteristics. That's what we talked about: region, sex, weight, age, marital status, alcoholism, cigarettes, exercise, healthcare cost, heart disease. Okay? When you're putting all the data into SPSS, first, I think you need to set this up, because this is gonna show the data on this side, on the variable view. So here's patient number 1, patient number 3, patient number 4, patient number 5. On the variable view, we talked about this yesterday. So let's pick region. So the region, the way it is described is, let me show you: Central America, North America, East America, West, South, and West. I'm just making it up. Okay. So what kind of variable that would be? Is it nominal? Is it ordinal? Is it dichotomous?
Nominal.
Yeah, it's nominal variable. It is in categories, but there is no order attached, right? So this is a nominal variable. Now, we talked about that, when we have a word attached to a variable, SPSS does not recognize that. So we need to change it to the numbers. Okay. So here we mentioned weight. And let me go to region. So so don't worry about the type. I think you pick, numeric for most of them, unless, otherwise. Don't worry about width. Don't worry about decimals. This sort of, help you, the label, when you put a label to something, it is going to help you remember what did I put there. So in region, what does that mean? Region where patients lives, right? So in this patient population, we are looking at different variables or characteristics to this patient population, and whether they lead up to heart disease or increased healthcare costs. For example, alcoholism, cigarettes, exercise, how is that related? So things that you need to worry about is region. You put the region, you label it as a region. Let me see. Sorry, go ahead. So I can put gender here. Sex is there, but just to show you. So it picked all these for me. So now I need to fill this up. Gender of patient. So I labeled it. Now, if gender is male and female, I'm taking it as a binary value. I need to attach a value to that. So 1 is male, 2 is female, right? So see, it translated your words into numbers. Now you can see if there's a missing data. If not, then all of that. Don't worry about the columns. Don't worry about align. Now I need to tell them what kind of variable that is. Now we don't have, dichotomous option here. So I'm going to pick for nominal here because there is no order attached. Okay. This is SPSS function. It's not my fault. They don't have, dichotomous option. Does that make sense so far? Any questions on this? So that's how you enter the, the variable into the variable entry. And why did we label it with the number? Because SPSS does not recognize words. SPSS only recognizes numbers. So that's why we need to translate that. Any questions up to this point? Okay. Okay, let me go back to the previous screen. And frankly speaking, ask the question that you want to ask, how stupid that may sound, that's okay. Okay, so let me move my Zoom controller. Okay. Now this is your variable view. So let's add another one. Let's add, give me an example, please, that you guys want to add. Anyone? I will go to the skewed thing. Okay, let's see number of coffee drinks. That's really excellent. So coffee drinks. So I want to add that. So see, it filled up rest of it. Weight is already there, so I don't want to do weight again. So number of coffee drinks, I want to label it drinks patients have every day. Okay, so I can remember that later. What did that mean? Okay, now if I'm using a number, like some people would, sorry, where did that go? Some people would drink 2 coffees, some people would drink 3 coffees, 4 coffees. What kind of variable that would be? Are you asking? No, Sonia, that will come up. Yeah. So good thing is that you don't have to be worried about continuous and discrete here. We just gonna pick for scale. Scale is actually numerical variable. Okay, so that's what you're gonna do. Okay, let's do this another way. Okay, I wanna do it. I picked scale because scale is an alternative term for numerical variable, right? I don't have any other options. So scale is for continuous variable. So if you see weight here is scale because that has a number attached to it. Age is numerical because it has a number attached to this. Average consumption of alcohol, cigarette, all of this. Is it that clear, Sarish? Okay. So let's do it another way. So for example, I'm gonna sort of use Kader as a guinea pig because I can. So let's say Kader drinks, we categorize Kader as that he drinks coffee very little. Sarish drinks moderate, and I drink heavy. I'm a heavy coffee drinker. Now these are not numbers, these are words, right? So I want to change it to the numbers, right? So what I would do, 1 little coffee drinker. Okay, I'll add this. 2 is moderate. 3 is heavy. Then I'll go there. Is it ordinal? Correct. Yeah. So that's how you do it. So that's how you change numbers backwards, and that's how you do that. Okay. Does that make sense so far? Okay, great. I'm just gonna delete those so it does not get screwed up. Okay, I cannot do that. Exactly, Kader. So that's really a perfect way to describe that. Now I'm gonna go to data view. So you see all of these variables, gender, coffee, we added that are in there, right? So these are all the variables. So this is individual patients. So that was variable view because all the variables were lined up. Here, all the patients are lined up. Does that make sense so far? Okay. So now I'm going to show you how to run for the frequencies. So, yesterday, where is my page?
Yes, because चलाना सिखा रहे तुम भी सीख लो. SPSS. मुझे लगा 90 मिनट की.
Okay, I think if you can keep your mic mute, you will learn more. So let's go to the frequency. So we discussed that when it is a scale variable or when it is a continuous or numerical or discrete variable, we use mean median mode, correct? Say yes, please. When we are using like categorical variable, that's when we use frequencies, okay? So let's run some, some frequencies. So this is my top bar. You can see that, right? You go to analyze, and I'm going to ask you next to do one for me. So I go to descriptives because frequency is a descriptive. It describes. There's no inference attached. I go to frequencies. Okay. Now tell me a variable that you want me to add here that you want me to use frequencies for. And remember, frequencies are only for categorical variables. One hint would be that ye jo futta type hai, that's a continuous variable. The rest of them are, ordinal or a nominal variable. So tell me one that we want to pick. Okay, we pick sex. Okay, I'm going to click here. I'm going to go here. We can go to region 2. Just give me 1 second. Let's go to region. Now, I also want to pull some pie charts. Okay, so I go to pie charts, go to this chart section, click here, go here, charts. Okay, so this is going to give me percentages, right? Frequencies. I go back there. And then now I press OK. And here a new window opens up that is called output style. So here are all the frequencies. So we picked for sex and region, right? So there are a total of 525 patients. 274 are male and 251 are female, right? 39.7% are males and 36.4% are male. No, we are not into correlation at this time. We are just putting up the frequencies because when you are describing your data in results, sometimes you have to tell them, okay, this many are males and this many are females. So we are just doing frequencies at this time. We'll do correlation next. So this is your percentage. Now we talked about the, absolute frequencies, relative frequencies yesterday. I don't want to go into that detail because I think we talked about that. Here are regions. So 134 in central, 73 in north, and so forth and so on. And here are some pie charts. Okay. Now, what I want you guys to do is, so this does not have to do anything with the confidence. It's just, measuring the data, what you have. It does not have to do anything else with confidence. So don't worry about that at this time. Okay. We are just running the frequencies. So let's see. I want to run frequencies. So tell me where I need to go. Anyone? Analyze. Good. So I clicked on analyze. What do I need to do next? Descriptives. Great. What I do need to do next? Frequencies. Okay. So I'm going to put these back. Okay. What do I need to do next if I want to run frequencies? Just pick a variable and then we go from there. Let's do a marital status. Okay. So I will add this here. What do I need to do next? Charts if you want, right? So I'm going to go here. I'm going to pick for pie chart. I'm going to say continue. And then what do I do next? Okay. So this is for marital status. Okay. Let's do another one. Okay. Where do I go? I know it seems, too simple at this time, but okay. Where do I go next? Descriptives. What do I do next? Frequencies. And remember, we are doing this for categorical. Okay, I did frequencies. Okay, I'm going to put this back. Okay, let's see if we pick another one. Let's don't do gender of patient or number of coffees because that doesn't have any data in this. Let's do heart disease. Good. Okay, I add this to variables. What do I do next? Anyone? Charts, if you want. Yes, Harish. Go ahead. So uske baad mein, okay, I will press okay, and this new output. You can also, copy paste this. Harish, you can ask your question.
Sir, my question is this, that how will we know that if the bar charts will represent the data properly or the pie charts are going to represent the data accurately? Which suits best? How will we know the best choice?
So that's up to you. Agar aapne pie chart karna hai, you can pick for pie chart. If you want to do like a bar, that's up to you. That's how you want to present your data. So it doesn't have to be one way or another way. Okay? So it's totally up to you. That's just graphical representation. So let's do, now we're gonna do, so those were frequencies for the, our new charts I did on the same page. Yeah, if you will keep it open, it's gonna keep added there. But I closed it, so it opened up a new page for me. So, but just make sure that you copy paste, and I'll show you it to you how to do that. So now I'm gonna run for, so we talked about categorical variables, how to do frequencies for them and all of that. Okay. Next, you go to analyze, and you want to run for, and let me test here a little bit. So you want to look at descriptives. Okay. I just want to try it myself first, and then we'll go from there. Okay, so let's do for this. Let me also pull my descriptive statistics. Analyze descriptives, explore. That's different. Okay, let's do this. I'll go to analyze. I go to descriptives. I go to, sorry, I'm forgetting this part. So let's see, wait. You put it here, your options, your mean, standard deviations, minimum, maximum. You want to look at skewness. Okay, so here you guys have to just, be patient with me. So let's say I want to look at the weight, and I want to look at the mean and standard deviations, okay? And usually, in most places, you only look up to 2 standard deviations. So I went here, I went to weight, I went to, I picked mean, standard deviation, minimum, maximum, and I will see if I can pick it another way. So I click here, and then it shows me that's not right way. Okay, so that shows me, give me 1 second. Let me just play with it a little bit. Okay, I think I got it. Okay, so for the same thing, so you go to analyze, you go to descriptives, you still go to frequencies. Now I'm going to put it back. So you want to look at the weight, okay? You go to statistics, you pick for mean, median, mode. That's what I picked for. I want to look at standard deviation. I want to look at skewness, though I don't know yet how to read that. So when I say, okay, please go. Statistics, I picked here. Okay. So do you guys see it pulled mean for me, standard deviation, and skewness, and all of that info? So what does that tell me? So let me do this again first. Let's learn about the operations of it. So I went to analyze. I went to frequencies. No, we don't choose frequency option for numerical variable. It's only for categorical variable. So let's I look at the age. I want add here. I go to statistics, and I'm gonna turn off charts here so it does not confuse you guys. I go to statistics. I already have mean, median, and mode. You can also look for quartiles. It will give you with the with the median. Then I do continuous. Okay. So now it gives me my descriptive statistics for the numerical variable. So my mean is 77.936. My median is 76.949. My mode is 66.8. My standard deviation is 5.66. Okay. Now you guys gonna tell me how I can get to another numerical variable. So where do I go first? Analyze, good. Okay, and where do I go next? I go to descriptives first, then I go to frequencies. Okay, I'm gonna put this back. Let's see, is there another one that you wanna pick? Anyone? So all of these are the average hours. Okay, let's add that. Average hours of, I think it's exercise or something. So healthcare is where healthcare costs, you want to add that? Okay, let's add that. So I want to look at both of them, average hours. So what do I do next? I go to statistics. And I pick for measures of central tendency, mean, median, and mode, standard deviation, quartiles. I won't look at skewness. I will read up on skewness and I will share with you. So what do I do next? I'll go to continuous. Do I pick charts here? No, because these are not categorical variables. Okay, so then I run, okay. So it shows me my mean for average hours of exercise per week is 8.92, median is 8.50, mode is 10. Let's see, standard deviation is 2.705. Okay, so that is your, I should have turned off frequencies too, but anyway, so healthcare, where is the healthcare? So this is total healthcare costs for people with heart disease. This is your mean, this is your mode, this is, mean, median, and mode. Do you see that so far? Any questions so far? Say no if you don't have questions. Or up, when you clicked on it, you can always copy paste these. And आप इसको word file में ले जाते हैं. Now let me explain that mean, median, and the mean and standard deviation from here. Okay, so let's go here. Let me open another pages. Okay, so I'm just gonna paste it here so we can remember. It did not, so okay, paste and messed up. Okay, let me just explain it there. So आपका mean जो है इस पे, that is 8.92 for average hours of work. And your standard deviation is 2.05. So your mean, your central values or your standard value is 8.92. Okay? For one standard deviation, that would be roughly about 11, would be upper value, and lower value would be roughly about 6. Roughly about. So people who exercise between 6 to 11 hours of exercise there, would be about 68%. Okay, और फिर आप जब, when you will add and subtract further, that will give you a second standard deviation. Where should that fall? Okay. So your central value here is 8.92. Your standard deviation is 2.0705. So that's how will you know. So plus minus karke, that will tell you your first standard deviation, and how many people would be in that first standard deviation. 68% should be there. And then so on and so forth about standard deviation. Any questions so far? Okay. I think someone had questions earlier. If they want to ask the question. Okay. Now let me show you how to know your data is normally distributed. Okay. So first you go to analyze. So no, median has quartile range. Only standard deviations come with mean. How do we know that 68% will be in the 68%? So remember we talked about normal symmetrical. So these are assumptions that are already known. Okay. Let me go there. So some of these are assumptions that are already known. Okay, 68% should be within first standard deviation. So some are already known, and they are known things that we need to know. We'll cover two more concepts, and then we'll call it a day. We go to analyze. We want to see if our data is normally distributed or not. So we go to descriptive statistics. We go to explore. And remember, symmetrical distributions only gonna be for numerical variables. Okay, your weight is representative of how it should be. So you add that to dependent list. You go to statistics, plots, and you see normality plots fit tests. You click that option, okay? And then you say, okay. So see, I did not close my previous window, so it's copying here. Okay. So now how to know if your data is normally distributed? So you look at these tests of the normality. And don't ask me what all these means. I will explain. I will repeat that. Okay. So if your sample size is less than 100, then you look at Shapiro-Wilk. Okay. If your sample size is more than 100, then you look at this Kogel's-Morse Semrenov test. Okay. And you see if data is significant or not significant. If it is significant, then it means that your population is not normally distributed. If it is insignificant, it means your population is normally distributed. Okay. So 0.134. I will see. So the test of significance is if it is less than 0.005, 0.05, it is significant. So when our sample size is more than 100, so we'll look at this Kogel's-Morse Semrenov test. So is it normal? It is significant or insignificant? Anyone? First tell me, so it is insignificant. It means our data is normally distributed. Okay, so let's do this again. Okay, let's go to analyze. Then we go to descriptives. Yeah, just give me 1 second. Go to explore. Now we want to look at another one. Let's look at average consumption of coffee. And you add to that dependent list. You have in plots, you have spec normality plots with test. You go there, you click on OK, and it's opening up there, right? So I go again to the test of the normality. If it is, so looking at this number 0.132, is it insignificant or significant? So remember, significance mean it should be less than 0.05. So it's insignificant. And this data is normally distributed. Now you guys gonna show me how to do it again. Where do I go first? Analyze. Okay. Where do I go next? Descriptives. Where do I go next? Explore. Okay, good. So I'm going to put this back. Let's pick another one. Which one you guys want to pick? You need to do it manually. I think we answered this question. So how do you, so sex is a categorical variable, remember? We cannot, do that on that. So
average.
So that's the logic. So you guys need to assume that at this time, and we'll talk, in future lecture. So total healthcare costs, I'm going to add that to dependent list. What do I do next? Plots, good. And I normality plot with tests. I go there, and then I run okay. So then it's going to pull up for me. Now tell me if test of normality, if it is insignificant or significant. Okay, so that means our data is normally distributed. So, to know more in detail, we need to take a whole biostatistics course. I'm just showing you what you need to know stepwise. Now, let me show you how to do the chi-square test. So chi-square test is done when there are two dichotomous variables, because that's a 2x2 chart, right? So it cannot be our nominal or ordinal. It can be only dichotomous, okay? So you go to analyze, you go to descriptives, you go to crosstabs. Now, tell me which one of these are dichotomous variable. If you don't remember, I'll just let you know. So here, so whatever is independent variable, that will go under row. So which one is independent variable? Let's say if we want to pick sex and presence of heart disease, which one is independent? Yeah, so that goes under row. And heart disease, because it's may get affected by sex, that goes under column. Now let me look at one thing. I'm just going to play with that. So here I click on chi-square, right? And I hit that. Okay, so this is the chi-square. So that just tells me that among males, now we need to go back. So I will explain that. So I need to, so I didn't look at this. Let me go back to my data variable. So what is meant by 1 and 2? How did that label that? So it didn't add the value to that. So for just, just assume that, 1 is presence of heart disease and 2 is absence of heart disease. So among males, there are 180 patients who have heart disease. Among females, there are 160 who have heart disease, and then that's how you do that. Now, how did I know what to do that, where to put this? So I went to analyze, I went to descriptives, crosstabs is option for the, okay. So this is the correlation between the independent versus independent variable. So you want to see, how many males have heart disease, how many females have heart disease. So which one would be independent variable? We don't check for association yet. We are just looking at the numbers. So correlation and regression, that they check for association. So let's focus on this now. So between sex So sex is independent. So I'm going to add that rule. And presence or absence of heart disease, this goes under column. I go to statistics. You pick chi-square test, how I picked. You run it. You go here, then you do that. So it's going to show me again. Okay. So Sania, I think I explained it. So row ke andar, in row, we'll add, in row ke andar, you will add an independent variable. Independent variable is that, if you're looking at, presence or absence of heart disease in male versus female, do you feel like, presence or absence of heart disease is going to affect their gender or sex? No. So, but presence or absence, male being male or female may affect whether they're going to have a heart disease or not. Male have a higher risk of heart diseases, right? So gender or sex becomes an independent variable. So that will go under dependent list. And whatever is dependent, that will go under factor list. So chi-square just tells you, if you do that, let me, so chi-square just give you, I think I came at the wrong place, maybe. Let me. So chi-square just tells us, whether males have, it's an easier way of knowing whether males have a heart disease, how many males have a heart disease, how many males don't have a heart disease, how many female, and how many female doesn't have a heart disease. Yeah, you can say that. So let me ask you this, if you want to come on, Mike. What's the relationship that exists between age and heart disease? What happens if your age increases? Anyone?
Yeah, sir, definitely. The risk of having heart disease increases.
So would it be other way around too? Like if you have heart disease, your age will increase? No? So because age is independent variable, heart disease is not affecting that. So age is independent variable, heart disease is a dependent variable. Does that make sense?
Yes, sir. Thank you.
Okay. So I think, this is it for today. Let me see if there is one. So far we looked at for today, yes, we cannot take age as, because age is a numerical variable in our data set, so we cannot take it, use it. Okay. Now, any questions? So that was it for today. You guys gonna, so chi-square.
Sir, I've got a question, sir. It's about like how do we put in the data for a group of patients? Like I have got 500 patients and I have got their ages, weights, genders, heights. So how do we do it manually on the SPSS? How do we fill in the data?
So you can put it in the Excel sheet and import that into SPSS, or you can do it manually in SPSS. There is no other way around this. Okay. So one last thing, that I wanted to share with you, since we were talking about t-tests and there were a lot of questions when to use t-tests. So when we discuss the association between, let's say, an exposure and outcome, when we want to see whether there is an association between both, that's when we do correlation analysis. Okay? So let's say we talked about age and heart disease, right? Whether our hypothesis is that with increase in age, the risk of heart disease will increase, right? So that's a correlation analysis. So based on, if you see the top line is different variables, and you use the top line when your data is normally distributed. Our data was normally distributed. So we'll use the top line. If your data is not normally distributed, that's when you use the bottom line, okay? So tell me, age in our data, was it a continuous variable? Was it, a dichotomous variable, or what kind of variable that was?
Yeah, it was sort of continuous variable.
It was continuous variable, right? And presence or absence of our disease, was it a continuous variable, dichotomous variable, ordinal variable?
Dichotomous. Yeah.
Dichotomous. So in this situation, we'll do the independent t-test, okay? This is just an example. We're going to talk more about that in detail in future, but I just wanted to show you, when he was talking about t-test, what was it meant by t-test, and in what situation we do the t-test, okay? But there's going to be a separate lecture on that too. Any questions so far before we end the session? Yeah, Abu Huraira. So chi-square test, it just tells you, it's a simple description. It's a descriptive statistics. It just tells you, it helps you understand. So let's see, if you have patients with, you want to see how many, you are looking for depression in male versus female. So it just tells you how many males have depression, how many females have depression, rather than calculating by itself. So SPSS does that very quickly for you. So age is not dichotomous variable. Age is numerical variable, but the absence or presence of our disease, that is a dichotomous variable. Okay. Anything else? One last question before we end this. Okay, I think people don't have any questions. I'll share the recording and then we'll go from there next week. Thank you very much. I know it was painful today, but I think we covered a lot. Thank you. Have a good day, everyone.